Hi, my name is Gavin and I am a physics tutor with Wyzant. Uh, Today we have a problem that was asked by Kelsey, and the question is, find the total force on the side of a cylindrical tank with a radius of 50 feet filled to a height of 40 feet with a liquid with a specific gravity of 1.5. All right, so let's draw a picture of that. So here's our tank. Now, so filled to a height of 40 feet. Like that. Now, this radius 50. Now, what happens when we fill a tank? It puts pressure on the walls of the tank, and the pressure distribution actually varies. As you go down, the pressure increases. So if we draw a picture of what the pressure profile looks like, something like this. Right. So at the surface of the water, here the pressure is actually 0. And today I'm talking about gauge pressure here. So that is, we're not taking into account the atmospheric pressure. We're just talking about the pressure difference between the outside and the inside of the tank. And so this is what you get. And now down the bottom, this max, well, actually anywhere along the depth of this tank, the pressure can be found by this formula: pressure equals rho g h. In this case, h is distance or depth. It's the depth. Okay, and g is 9.8, and rho is the density. So this depth means how far down you go, and that's why it's a straight line linear function here, because the further you go down, the greater the pressure. Now, the question's asking for what's the total pressure on the side of the tank. So that would take into account right around, as you go around, right around, there's pressure all the way around. Okay. Now we can think of this, if you make a cut down here, for example, what you'd end up having is, and if you after you cut the tank there and you unravel it, you could think of a one long flat wall like that, and this pressure distribution here, I'll show again here. All the way along this wall. And so if we can find the pressure, the total force on this. Now the total force equals now to do this, what we can do is total force equals, well, since this pressure is varying, we can actually call, and since luckily it's varying in a linear way, so we can say the total force is the average pressure times the area over which it acts. Now, the area that it acts on is this total area here, A. This is 50 feet radius. So the distance there, this distance here is going to be the circumference of the tank, because it's the distance right around, which is 2 pi r. The height here is the height of the that's 40 feet. We'll just call that h. and pressure here. Now the pressure at the bottom is rho g and times the depth, which is this. We're going to call this h. So it's rho gh. The average pressure is actually half of that, because at the top here we have zero pressure, and at the bottom we have the full rho gh. So therefore, in the middle we would have half rho gh, and actually that's the average pressure. So if you like, you could think of this pressure distribution as being equivalent to this. When it comes to total force, you get the same answer if you think of pressure distribution like this, except that the orange distribution is constant, about half rho gh. Okay, I'll just take that out for a moment anyway. Okay, so therefore, the average pressure is a half rho gh times the total area, which is 2 pi r times h. All right, that's it. We just need to calculate that. So the half and the 2 cancel. So we have pi r rho gh squared, which equals specific gravity, and that's something else. The density equals the specific gravity times the density of water. So we have 1.5 times the density of water. So that's going to equal 1.5 pi r times the density of water times gh squared, density of water. Okay, from here, because I don't know whether we want the answer to be in international system units or if we want them to be in empirical units, what we'll do, we'll leave this here. I'll let you finish it from here. You just need to substitute in for h. Either put in 40 if you want the units to be in empirical units, or convert it to meters and put it in as meters. Likewise with the R, convert that to meters if you want international units. And rho, and yeah. All right, let's leave it there, and that's how you find the total force on the side of the wall of a cylindrical tank.